Hello and welcome to Algebra 2. We are starting here with Chapter 1, Section 1, Expressions and Formulas. So a lot of what we're going to talk about is a bit of review, and so let's just get started. So I'm going to start off by erasing some work that I was doing before we got together, and I want to talk about our vocabulary. For the most part, I like to start off a lot of videos with vocabulary so we can get an idea of what we're going to be talking about. So in this case, we're talking about order of operations, which sometimes is broken down into the mnemonic device PEMDAS, right? And um, the P standing for parentheses, the E standing for exponents, M and D standing for multiplication and division. Notice I'm writing them side by side because they are equivalent, and we just do multiplication and division from left to right, and addition and subtraction, that is done left to right. So this is like kind of our marching orders anytime we have an algebraic problem to do, or anytime we're simplifying or anything. And so I like this key concept that the textbook gives us, tells us about order of operations in a little bit more detail. So when we talk about parentheses, we're talking about this symbol. We're also talking about brackets and braces. So anytime we see any of these three symbols, we know that that supersedes everything else. We got to go to the core and actually do what's in that parentheses first if we can, or in that bracket or in that brace. Additionally, a fraction bar is in a sense similarly considered a kind of a grouping symbol, right? Because we know that we've got two separate parts, which is the numerator and denominator. So technically the numerator is grouped together with all the elements or terms up there, and the denominator is grouped together. So here I know I would add 5 plus 7 before I deal with dividing this too. So evaluate all powers. We know that that deals with exponents. Do multiplication and or division from left to right. It is so important not to think that multiplication is more powerful or it should be done first before division. So that's something we need to keep in mind as we do our problems. And addition and subtraction are also equivalent, and you'll do those from left to right. When we talk about variables are what makes algebra sometimes frustrating to some students. It's really just a letter or a symbol that is used to replace a number. And so variables we would see could be anything like Q, T, even funky little symbols that we may not be familiar with, but I'm going to do theta. Theta is a Greek letter that's sometimes used to represent angles. So all of these are variables, and the reason why they're called variables is because they change. So variables change because they vary, right? If I solve a problem x plus 4, in this problem x plus 4 is equal to, let's say, 7. In this problem, x is clearly equal to 3. But later on, I could have a problem that says x plus 1 is equal to 9. Well, clearly in this problem, x is equal to 8. And therefore, variables vary. They change with each problem. And we need to keep that in mind, that that's all that's going on when we're dealing with variables. Algebraic expressions. When we have algebraic expressions, it is expressions that, or number sentences in a way, right, that deal with variables. So 2x is actually an algebraic expression. 4 plus 3y minus z is another algebraic expression. Another example of an algebraic expression is, I don't know, 3 pi r times h is an algebraic expression. What I want you to notice is that algebraic expressions contain variables, but they also noticeably do not have an equal sign. Expressions don't have equal signs. Equations, on the other hand, do. Notice equation has the word equal in it. And so that's one really quick way to distinguish between an expression and an equation. And then finally, when we talk about a formula over here, when we talk about formulas, we are talking about an algebraic expression used to relate equivalent amounts. So we could say perimeter is equal to 2 times the L plus 2 times the width, right? Or area is equal to length times width. Very familiar formulas. Notice these formulas are equations because they have equal signs, and they also have variables in them. So they are a formula is really an algebraic expression that relates quantities. Now that we've gotten through some of the vocabulary, let's try some problems. So here in example 1, we're going to simplify this expression, remembering in the back of our mind that we are working with a model that tells us exactly how to proceed. So we first need to go into the center of the problem. We go into the brackets, but inside the brackets we see that there's parentheses. So I'm going to deal with that first. So if I were to do this problem, I'd first subtract the 10 minus 4 to get 6. And then I'm going to pretty much write everything back the way it was before. If you notice that when there is no symbol given between two numbers, that means that we multiply. If there's only a parenthesis there, we know that we have to multiply. So I'm anticipating this is the multiplication portion of the problem. Again, I'm still working in the brackets. What would I do? Should I add? Should I multiply? I have this power. Exponents supersede addition and multiplication. So I will get 2 times 36. This 6 squared is 36, still plus 3. And then I'm going to divide everything by 5 when I'm done. I'm going to add here, I'm going to multiply first because multiplication supersedes addition, and I get 72 plus 3, that's still in brackets, divided by 5. Even though division supersedes addition, I've got to do what's in the bracket first. So I first get 75, divide that by 5, and now I'm on my way to the answer. 75 divided by 5 is 15. And so what we've done is we've found the value of this expression. We've basically just worked the problem out. Let's evaluate an expression. When you're evaluating an expression, what you're doing is figuring out the value of the expression with certain values given about the variable. So what I do with this problem is I'm going to rewrite it. X squared minus y times the quantity of x plus y. If x were equal to 8, well, let me replace all of my x's with 8, and y is equal to 1.5. And I'll obviously replace y with 1.5. Now that I've done that, I've got a similar problem to the last one, and I've got to honor my parentheses, because that's the thing that I'm supposed to do first. Remembering that this means multiplication with whatever I get, so I have a 9.5 here. The next thing I'm going to do is I'm going to deal with this exponent here. So I know that 8 to the second power is 8 times 8, which is 64. Now I've got 64 minus 1.5 times 9.5. You guessed it, I'm not going to subtract. I'm going to multiply because we remember multiplication supersedes subtraction. So when I multiply 9.5 by 1.5, I end up with 14.25, and then when I subtract the two, I'm going to get 49.75 as my final answer. Okay? Let's take a look at expressions containing a fraction bar. So again, these are very similar to the last couple of problems. We're going up in difficulty a little bit, but the same idea applies here. Let's rewrite the problem with the substituted numbers in. So for A, I'll put 2, so I get 2 to the third power plus 2 times b, which is negative 4. Sometimes putting parentheses around those is really helpful to just keep track of the signs. And then I've got c squared. C to the second power would be negative 3, quantity squared minus 5. And so now it's showtime. So what I need to do is remember that in a way there's the magical brackets that keep the numerator and denominator separate, meaning I need to simplify the numerator and denominator separately as best I can before I can proceed. So let's take a look at the top. At the top I've got 2 to the third power, which I know is 2 times 2 times 2, which is 8, plus 2 times negative 4 times negative 3. Now I'm going to go through and multiply, not add. Multiplication supersedes addition. So at the top, this is going to become 8 plus 2 times a negative 4 is a negative 8. And I'm going to multiply that times negative 3. And then I'm going to just focus on one area first. So I'll leave this alone for a second, and I'll continue on down here. My numerator here becomes 8 plus negative 8 times a negative 3 is a positive 24. And so now that I've finished that, I'm going to now finally come down and deal with my denominator. I'm sure you're probably doing this faster than me, which is totally fine. I just want to make sure it's clear exactly what we're doing. Negative 3 to the second power is negative 3 times negative 3, which is a positive 9. When I subtract 5 from that, I'm going to finish my denominator. So now I can add up here. 8 plus 24 is going to give me 32. And 9 minus 5 will give me 4. And I love when a plan works together because 4 goes into 32 very nicely. It goes in 8 times. And I see that I'm done. I've evaluated that. So we're going to move on to our final example of the lesson using a formula. We talked about formulas, and this formula is the area of a trapezoid. Its area is equal to 1/2 the height of the trapezoid times base 1 plus base 2. So here h represents the height and b1 and b2 represent the measure of the bases. Find the area of the trapezoid below. What I want you to take a look at, this is a formula you may have seen before, maybe not. Base 1, that's a little bit too thick. Let's see if I can fix that. Try again. All right, so base 1, let's call that this guy here, B1, we refer to as one of these bases. So that would be, let's say 16. And base 2, we can refer to as this larger base down here. And obviously the height would be this section right here. So we kind of have an idea of how to substitute what number is in. And so let's go ahead and get started with that. So what I have is, again, I really like to write down my formula so I can keep in mind what's going on, and it helps me to remain really organized. So I wrote down the formula and I'm going to substitute. The area is equal to 1/2 the height. Height in this case is the green part, which is 10, times base 1, which we're going to call 16, and base 2, which we're going to call 52. And like any good mathematician, we always hang on to order of operations. So I know I'm going to do what's in parentheses first. And what's happening here, let's go ahead and rock out. 16 plus 52 is going to give me a 68. So then I'm going to take 68 and I'm going to multiply. Now I literally could multiply from left to right because this is 1/2 times 10 times 68. Are you guys walking with me? Hope so. So then I have 1/2 times 10, which we know to be 5, right? Times 68. I simply just rewrote the same thing again. That didn't make sense. My bad. So 10 times that is going to be 5 times 68. Then when I multiply all of that together, I am going to get the fabulous answer of 340. And I know sometimes I am lazy. I am truly lazy, and I sometimes will leave 340 and say we're done, but we're technically not, because what are we talking about? Since we're referring to area, we're talking about square units. So we're talking about little square inches. If this were literally 52 inches and this were literally 16 and this were 10, we could actually fit 340 little tiny square inches. So we honor what we're talking about by doing square inches, something like that. Or you could do 340 inches squared with a little 2. Both of those are acceptable answers. So now that you've gotten this wonderful information, I want you to take the text, and I'd really love it if you would try problems 9 through 10, numbers 17 through 51 odd. So that's every other problem. And then you're going to do 59 through 66 all. Let's take a real quick look at that. So here's your textbook. Our assignment is going to be found on page 9, as I said before, and we're going to look at number 17 through 51 odd. Good practice. And then we're going to come down here. For the time being, we're going to skip some of these word problems. They're helpful, but not really what we need to focus on. And then page 10, I want you to do 59 through 66. And what we're doing is working on square roots. Please feel free to send me a question if you have any questions. And I look forward to talking to you soon about the work that you've done. Thank you very much.